Welcome to the second test of color difference detection with CR200 color sensor. In this video I show you with the real samples of foam if one side is coated or not. We can detect if there is a color difference between the two sides. We need an object distance of 6 centimeters of each side. This is necessary for a maximum of movement. So we have here the 5 parts of foam. One thing is uncoated on both sides, so there's no color difference between this side. Here we have a brown one, and I have prepared it a little bit, cut it things away, the coating away on one side, so that we have comparable conditions. This part that we can see here is a little bit aged, so the color is not the same on both sides, so we can take this not in our considerations. To adjust the signal leveling, we make the auto set range with the foam part in the midst of the two optics, and that both channels match good over the whole color space. We use the inter-channel balancing tool of the software. So we take 4 colors, the uncoated foam part, the yellow one, the blue and the brown. And for these points in the color space, we adjust the 2 channels so that there's a good matching between these channels. So when we have performed the inter-channel balancing, we teach in the software one single color, and this is the color difference of 0. So we can correct by typing in this color to 0, put 0, 0, 0, and set the tolerance. A tolerance value of 9 is a good choice here. So now we can move the uncoated part to the left side, and we see that the colors of both sides are the same. We see the yellow light, that means the same color of every side. So now we can move it to the other side, and it's always the same color. We close the software. Now we can see the yellow light on the sensor itself. You see when we move, the light remains on, and so that indicates that we have the same color of both sides. Now we repeat this with other foam parts with different colors. It works also in the same way. And this also works with the coated parts. So there's a huge saturation in color, and also the color difference is shown, that is 0. So now I move it, and we detect a color difference, and this works until 4 centimeters. So then the light switches on. So we take the next part, the yellow one. We see here the color difference is shown over the whole range. The same color is also shown over the whole range. The light goes on. The most critical part is the big foam. The detection of the foam without coating is the same as for the other parts. But due to the fact that the coating has a weak saturation, so the colors are very similar of each side, and we only have a range of 1 centimeter to move in one direction. I was really surprised by the fact that the movement range of the object is so high. And the reason for this is in the characteristics of the optic. We have a maximum intensity at 6 centimeters, and if we move the object farther from the optics, the signal decreases, and also if we get nearer. So there's a compensation between the 2 channels. This arrangement is the best choice for a maximum of movement range. any angle constellation of object and sensor will decrease the movement range.